Hello, I am Syntax Sugar, and today I will be introducing tail recursion. So, uh, most code is done through for and while loops, which I consider pretty boring, but we can do it in another way that will be a lot more eloquent and elegant. And this exhibition in this video will look at three things concerning this concept: the basic array sum, and a maximum element finder, and a speed comparison to the imperative method. So here's the regular summing method as a function. You can see it's just very basic. You have the cursum, and then you go through every element in the array, and you add it to cursum, and you return in that. What we're going to be doing is, instead of relying on loops to do the looping through the function, we're going to be letting the function call itself, and this is recursion. So what we're going to need to do is create a base case for the function, which is the point where you could say the function keeps on digging, and then once it reaches the base case, we'll stop digging and start climbing back up. So here's the snippet. What it does is we initialize the function, and then we return summing of array sub 1 from 1 to the end of the array. So the first element, array sub 0, is not going to be called in the next call. So then carsum plus array sub 0 is going to be what our carsum is. We're going to take the first element, add it to carsum, and then continue the summing function from there. And our basic case, the point where we stop digging, is going to be once the length of the array is 0. And we can test that this code works, and we get 9, which is the true answer. So here's the side-by-side comparison, but this time for max and array function. Here we set car max to a very small number, go through the array, and if our current element is greater than the car max, we set it to the car max, and we return car max. But here, what we do is we initialize our base case. If the length of the array is equal to 0, we return car max. But here we need a conditional. So what we do is, if the array sub 0 is greater than current max, we return max and array of the next elements, the array and the next elements of array, and we set our current max to array sub 0. And then otherwise, we just set it, we just continue eating through the array with our car max the same. And we can see that it returns 7 as it should. So the concept behind these functions is that recursion is very slow, and it's always taught that it is very slow. But here we're using really a special case of recursion that is called tail recursion. And what tail recursion does is that it keeps the recursive call in the return statement. And doing this really allows programming languages to optimize tail recursion in a way that stops it from facing the problem that faces most recursive code, which is stack overflows. If you've ever faced one, they just keep on having recursive call after recursive call after recursive call, and that ends up taking a lot of memory in the computer. But tail recursions are able to be optimized. But sadly, Python doesn't implement tail end recursion, and we're left with, although a very fast speed, not a very good one, which is 0.0009, which is slower by a factor of 10, I would say, than the regular imperative method. And this is only going through a range from 1 to 500. Imagining a bigger list would be the difference would be very stark and contrasting. But there is hope for tail end recursion in other languages that implement this, and I think there should be no other place to look for languages that implement tail end optimization other than functional programming languages, which are the people who have pioneered the concept, I would say. And due to this, I wish to really uncover and discover more functional programming languages with you, the viewers. So if anybody has a recommendation on what language to learn, I think I'll be hoping to learn Elixir. But any recommendations, any suggestions are very kindly welcome, and I thank you for your very kind listening.